Imagine spending like an hour every single day meticulously dusting your living room.
Oh, that sounds completely exhausting.
Right. You're wiping down every bookshelf, uh, every ceiling fan blade, the baseboards, only to wake up the very next morning and find everything covered in a fresh, thick layer of grime again.
Yeah, most people would just assume they're bad at cleaning at that point.
Exactly. But for one homeowner in Oklahoma, this wasn't an issue of bad housekeeping at all. Her house was actively trying to warn her that her HVAC system had essentially turned into a toxic debris vacuum.
Which is such a terrifying thought, honestly.
It really is. I mean, we tend to view our homes, heating and air conditioning as a strictly binary thing. It either blows the temperature we want or it's completely dead in the middle of a brutal summer afternoon.
Right, there's no in between for most of us.
But there is actually a whole spectrum of subtle, non-temperature related symptoms operating just under the radar.
And those whispers are actually crucial diagnostics. I mean, understanding them is more critical now than ever before because, well, modern building codes have fundamentally changed how we interact with our indoor environment.
How so?
Well, we are sealing homes incredibly tight these days to maximize energy efficiency. So we are effectively wrapping our living spaces in giant impermeable plastic bags.
Wow, that paints a pretty suffocating picture.
It does. And if the mechanical systems inside that home aren't perfectly filtering and conditioning that trapped air, you are no longer just dealing with a drafty room. You are actively breathing in a concentrated soup of whatever is trapped in there with you.
And that brings us to the source material for today's deep dive. We are looking at a really fascinating interview with Dave Hartzell. He's a master HVAC technician.
Yeah, with something like 45 years of experience, right?
Yep, 45 years working out of central Oklahoma, specifically around the Kingfisher area. And what's cool is he approaches these systems not just as a mechanic swapping out broken blower motors.
He's almost like an environmental diagnostician for your living space.
Exactly.
Yeah.
So our mission today is to decode the weird symptoms happening in your home. You know, the relentless dust, the condensation on the glass, the unexplainable smells.
To really figure out if your system is the hero or the villain of your indoor air quality.
Right, because it requires a major shift in perspective.
It really does. You have to stop just staring at the thermostat on the wall and start looking at the actual air you are moving through the house.
Okay, let's unpack this by looking at the visible clues first. The physical dust, the dirt, and the baseline foundation of all of this, which is airflow.
Always comes back to airflow.
Always. So I want to go back to that homeowner I mentioned earlier, the one located in Okarche, who was fighting that daily losing battle against dust.
Oh, right. The one dusting every single day.
Yeah. So Dave comes out to investigate, and he discovers the system is pulling a massive amount of particulate matter, but not from the living room.
Where was it coming from?
He pokes his head up into the attic and finds a gaping hole around the return duct boot.
Oh, no.
Yeah. The system was basically taking the absolute path of least resistance.
Well, the physics of a return leak are pretty unforgiving. I mean, the return duct is the suction side of the system, right? It's designed to draw conditioned air from your hallway, pull it through a filter, and recirculate it.
But air behaves like water.
Exactly. It will always flow through the easiest available opening. So instead of pulling air from the house, this gaping hole in the attic meant the system was just aggressively sucking in raw fiberglass insulation fibers.
Yikes.
Yeah, pulverized red dirt, stagnant attic air, just pulling all of it directly into the airstream.
It makes me think of like trying to breathe through a tiny cocktail straw while simultaneously vacuuming a heavily soiled ancient rug.
That is a very vivid and accurate analogy.
Right. You are just forcing pure debris into the mechanical ends of the house, basically bypassing the intended filter almost entirely.
So how did he fix it?
Dave's fix was twofold. First, sealing the ductwork with mastic to actually isolate the system from that attic environment.
Makes sense. Stop the bleeding first.
Exactly. And second, switching out her 6-month-old cheap fiberglass filter for a Merville 11 heated one.
And, establishing a baseline for maintenance there is really critical.
What's the standard rule of thumb now?
Well, the general recommendation for homes with pets or those situated in high-wind, dusty areas is a filter change every 30 to 60 days.
Okay, so pretty frequently.
Yeah. A standard pet-free home tops out at maybe 90 days. But rather than relying strictly on the calendar, Dave actually recommends the hold it up to the light test.
Oh, I like that. That sounds way more practical.
It is. You just pull the filter out of the ceiling or the wall grate. If you hold it up to a window or a ceiling fixture, and light cannot pass through the material at all.
It's dead.
Right. It has completely stopped functioning as a filter. It is now just a physical obstruction.
Which raises a really fascinating paradox for anyone trying to improve their air quality. You walk into a hardware store, you see the ultra-expensive, hospital-grade MRV16 filter on the shelf.
Oh, the fancy ones.
Yeah, and you naturally assume you are doing your family a massive favor by buying the absolute best filtration available. But Dave strongly warns against this.
Yeah, he does.
Wait, you're telling me I should actively avoid buying the highest quality filter at the store? That feels completely backward if the goal is clean air.
Well, what's fascinating here is how well-intentioned upgrades can fundamentally destroy standard residential machinery.
Really? Destroy it.
Yeah. Slapping a MRV 16 filter on a standard unit creates a scenario where the blower motor hits a literal brick wall of static pressure.
Oh, because the material is too thick.
Exactly. The density of the pleated material required to catch those microscopic particles, it requires a commercial-grade motor to actually push air through it.
So the normal residential motor just struggles. It overheats and ultimately chokes the entire airflow cycle because it simply lacks the horsepower.
Right. And that severely restricts the volume of air moving across the indoor evaporator coil.
And that coil gets cold, right?
Yeah, very cold. In the summer, that coil is ice cold. So if you don't have enough warm, ambient air from the house moving over that metal to absorb the cold, the refrigerant inside drops below freezing.
Oh, wow.
Yeah, the ambient moisture naturally collecting on the coil just turns to ice. You will freeze your entire system solid, completely encasing the coil in a block of ice.
Simply because the filter you bought was too restrictive. That is wild.
It happens all the time.
So we've got a frozen coil buried inside a dark, warm metal box in the attic, or maybe a hallway closet. Eventually, the thermostat reaches its temperature, the system shuts off, and that solid block of ice rapidly thaws.
Which is a huge mess.
Right, it overwhelms the drain pan. Now you have standing water breeding mold inside the ductwork, which perfectly explains the sudden musty smells Dave mentions.
Yeah, water in the dark is never good.
But ruined drywall and moldy ductwork are just property issues. What happens when that trapped moisture actually starts changing the atmosphere of the entire house?
Well, you start seeing the invisible intruders manifest visually, usually as condensation on the windows during a hot summer morning.
Like it's sweating inside.
Exactly. That visual cue indicates the indoor relative humidity is hitting like 60 to 70%.
Which is way too high.
Way too high. It is completely missing the target zone of 30 to 50%. That's the range where human comfort is maximized, and biological pollutants like mold and dust mites really struggle to survive.
So hitting 70% humidity means the system is fundamentally failing at half of its core function.
Precisely. Because we all know air conditioners dehumidify as a natural byproduct of the cooling process. They pull moisture out of the air as it passes over the cold coil.
And Dave attributes some of this failure to dirty coils restricting airflow or bad window seals letting humid outdoor air seep in.
Sure, those are common culprits.
But he pointed out a major flaw in how modern systems are sized that completely defies conventional wisdom. We assume scaling up the power of the AC scales up the comfort.
It's the American way. Bigger is better.
Right. If I'm replacing a unit, I want the biggest, most powerful machine to beat the summer heat, right?
Wait, so having an AC that's too powerful is actually a bad thing?
Apparently so.
Yeah. If we connect this to the bigger picture, it all comes down to the thermodynamics of latent heat removal. Scaling up the physical tonnage of an AC unit often destroys its ability to dehumidify.
How does that work?
Well, an oversized unit will basically blast the living space with a massive volume of freezing air. It drops the temperature on your thermostat to your target in perhaps 10 or 15 minutes.
Okay. Sounds good so far.
But then it immediately shuts off.
Oh. It satisfies the thermostat's temperature requirement before it has a chance to actually condition the air.
Exactly. In the industry, it is called short cycling. Dehumidification requires sustained time. The system needs a long, slow run cycle to systematically pull the required volume of air across the cold coil.
Like wringing the moisture out of the environment like a wet sponge.
That's a great way to put it. Short cycling leaves you with a house that reads 70 degrees on the wall, but feels completely cold and clammy to the touch because the moisture is still just suspended in the air.
So the duration of the process is just as important as the physical temperature drop.
Absolutely.
And we see a different extreme entirely in the winter. Gas furnaces effectively bake the moisture out of the air through the combustion heating process, driving humidity levels dangerously low.
Oh, winter static is the worst.
Right. You deal with intense static electricity every time you touch a doorknob. Your hardwood floors start shrinking and separating, and you're waking up with bloody noses.
Which forces homeowners to install whole home humidifiers tied directly into the ductwork just to artificially inject water back into the airstream.
It is just a constant mechanical balancing act. Too much moisture in the summer breeds biological growth.
And too little moisture in the winter damages the physical structure of the home and really irritates your respiratory system.
Yeah, this constant battle with moisture and dust is incredibly frustrating. But we need to elevate the conversation beyond just physical comfort.
We're talking about health now.
Yes, Dave's role frequently shifts from a mechanic fixing machinery to an environmental diagnostician addressing severe health and safety threats.
Like asthma triggers?
Exactly. He talks about households where a child relies heavily on an asthma inhaler indoors, but is perfectly fine playing outside in the yard.
That's a huge red flag.
It is. So he opens the system and finds the ductwork lined with mold spores from a previously frozen coil paired with a completely clogged filter. The house itself is operating as a contained allergy delivery system.
That is horrifying. But, while mold and particulate matter are these insidious long-term triggers for respiratory issues, there is an immediate lethal threat that gets checked on every single gas heating call.
Carbon monoxide.
Yes. Inside a gas furnace, there is a component called the heat exchanger. It basically acts as the metal barrier containing the actual fire, the combustion. The air from the house blows over the exterior of this intensely hot metal to warm up, while the toxic combustion gases inside the chamber are vented safely out of the roof.
But over years and years of operation, that metal is expanding and contracting thousands of times.
Exactly. It undergoes immense thermal fatigue, and eventually that heat exchanger can develop a hairline crack.
And that's all it takes.
That's all it takes. Once compromised, the positive pressure from the blower motor pushes odorless, invisible, and tasteless carbon monoxide directly into the ductwork,
Distributing it evenly into every single bedroom in the home.
Yeah. And the symptoms mirror a severe flu, headaches, nausea, dizziness. A dedicated functioning CO detector is absolutely a non-negotiable piece of safety equipment in any home with gas appliances.
Here's where it gets really interesting, though. We spent all this time talking about sophisticated filters to catch dust and mechanical checks to prevent carbon monoxide leaks, but Dave points out another completely silent threat.
What's that?
Volatile organic compounds, or VOCs. These are the chemicals constantly off-gassing from modern building materials.
Oh, right, like new paint and synthetic carpet?
Exactly. Memory foam mattresses, particle board furniture, and those standard MRV11 pleated filters we talked about earlier, they do absolutely nothing to stop them.
Because they are gases, not physical particles.
There you go.
You would need heavy, specialized, activated carbon filtration to even begin capturing VOCs at the return grill.
Which most people definitely don't have.
No, they don't. And this really exposes a profound irony in modern building science. To achieve peak energy efficiency and lower our utility bills, we are sealing homes so tightly that we are locking ourselves inside with our own chemical off-gassing.
So the indoor air becomes completely stagnant and contaminated because it literally has nowhere to escape.
Right.
So to protect ourselves from these complex, high-tech chemical compounds trapped by our high-tech building materials, a 45-year veteran of the HVAC industry recommends the most remarkably low-tech solution imaginable.
What did he suggest?
He just says, crack a window.
Seriously, just open a window.
Yeah. Run the bathroom exhaust fans. Let the house breathe.
Well, the necessity of fresh air exchange really cannot be overstated. A closed-loop system simply recirculates the same stale air over and over again.
Which is gross when you think about it.
It is, whether it's achieved through mechanical ventilators, which, exchange indoor and outdoor air while retaining the heat or cooling energy, or merely opening windows on a mild afternoon. Purging the environment is essential for holistic home health.
We just cannot rely entirely on a closed system to filter out continuous chemical emissions.
No, we can't.
And yet people constantly try to solve this with gadgets instead of actual ventilation. You see UV lights marketed everywhere as the ultimate indoor air quality solution.
Oh, I've seen those ads.
Yeah, they make it seem like you install a bulb in your ductwork and suddenly your air is pristine.
But that's not how it works.
Not at all. Dave clarifies that they serve a highly specific function. They sterilize mold bacteria directly on the surface of the evaporator coil to keep it clean.
Okay, so they clean the machine, not the air.
Exactly. They are absolutely not a panacea for air quality. A UV light doesn't patch a return leak in your attic, it doesn't lower 70% humidity, and it certainly doesn't filter out VOC's off-gassing from your new couch.
It is merely one specialized tool in a much larger diagnostic toolbox. I mean, relying on a UV light to fix a dusty, humid house is a fundamental misunderstanding of how the system operates.
That brings us to the strategic reality of actually fixing these problems. Diagnosing a house as a holistic system takes real expertise, and we need to look at the financial landscape of doing this in 2026.
Because things have changed.
The playbook for financing indoor air quality upgrades has completely shifted in recent years.
The previous strategy for many homeowners relied heavily on those massive government subsidies to offset the cost of incremental upgrades.
Right. But those highly publicized federal Section 25C and 25D tax credits actually expired at the end of 2025.
Yeah, you're gone, so you can't just write off a dedicated air purifier or a duct sealing job on your taxes anymore.
Dave laid out the current reality for a state like Oklahoma. The utility rebates still available, like OG&E, offering up to $1,500 per unit, or the OEC rebate of $400 to $700 per ton.
Those are structured strictly to incentivize massive energy efficiency leaps.
Exactly. You only get that financial help if you are installing a brand new high-efficiency HVAC system or, like, converting the property to full geothermal.
Because the utility companies are prioritizing grid load reduction, they are no longer subsidizing the Band-Aids for your personal air quality.
Which means standalone indoor air quality equipment, whether it's a $1,200 to $2,500 whole home dehumidifier, a dedicated air purifier, or a UV light, is now entirely an out-of-pocket expense.
And this fundamentally shifts the diagnostic strategy for a homeowner.
It forces you to find the root cause rather than throwing expensive hardware at a symptom. I mean, why spend $2,000 on a whole home dehumidifier if the core problem is just a $150 fix to seal a gaping hole pulling humid air from your attic?
That makes perfect sense.
A professional diagnostic fee from a technician like Dave might run about $111, which he actually credits toward the actual repair. That is a fraction of the cost of masking a symptom with unnecessary gadgets.
And when evaluating the root cause across thousands of homes over 4 decades, Dave's conclusion is pretty striking.
What's the number one issue?
The underlying issue behind the relentless dust, the trapped moisture, the phantom smells, and premature system failure is almost never a lack of sophisticated equipment.
It's not.
No, it is simply airflow.
So what does this all mean?
Yeah.
It means the basic physical movement of air through the ducts, across the coils, and out the supply vents is the foundation of everything.
Everything.
Closed room vents because you aren't using a guest bedroom, crushed flexible ducting in the crawl space, or a suffocating MRV16 filter, they all choke the system at its most fundamental level. If the air isn't moving properly, nothing else functions.
This raises an important question, though, about how we fundamentally view our homes. The HVAC system operates as the mechanical respiratory system of the structure.
The lungs of the house.
Exactly. Those lungs cannot heat, they cannot cool, they cannot dehumidify, and they cannot filter out dangerous particles if the literal breath of the home is choked off by completely avoidable obstructions.
We demand these complex machines to perfectly curate our indoor environment, but we frequently starve them of the basic air volume they need to actually execute the thermodynamic process.
The health of your indoor air is inextricably linked to the mechanics of your HVAC system. They aren't separate issues at all. They are the exact same conversation.
So if you are noticing those subtle symptoms, dusting every 3 days, foggy windows in July, or waking up with unexplained headaches, do not ignore the warning signs. Your house is communicating with you long before the equipment inevitably fails on the hottest day of the year.
Treat the root cause, not the symptom. Have the entire system evaluated as a living, breathing mechanism.
You have to examine the ductwork integrity, the sizing calculations, and the baseline airflow before investing in standalone purifiers, or just expecting a new filter to solve what is essentially an architectural problem.
Listen to what the house is telling you.
Absolutely.
Yeah.
But it leaves us with something much deeper to ponder. Just think about this contradiction. If our modern building practices are creating homes so airtight and energy efficient that we are actively trapping toxic pollutants inside.
Basically suffocating ourselves.
Right, forcing us to rely entirely on artificial mechanical lungs just to breathe safely in our own living rooms. At what point do we need to fundamentally rethink how we design human habitats from the ground up?
That's a heavy question.
Are we building healthy homes, or have we just engineered highly insulated containment zones? Think about that the next time you hear your AC kick on.